Hey guys, this is Shobit.
This is Michael.
And this is Harshit.
And we are all second year undergraduate students in Bennett University pursuing computer science, and this is our fourth semester project. Our project is a research project, and we're working on prediction on chaotic time series with kernel adaptive filtering. So there was a need for a better accuracy in predicting values in a chaotic data sets. So what we've done is we've made use of already available algorithms and optimized them to create the best fits of parameters on a chaotic time series.
This project has been implemented on MATLAB, which is a proprietary software. We made use of code available on the internet in the form of algorithms and made use of data sets which have been provided to us to create optimization functions which are randomized within ranges that we found to be viable through extensive testing. We have committed parameter optimization on a total of 5 algorithms, which is the probabilistic LMS, the KLMS, the QKLMS, the FPKLMS, and the MKNLMS. The parameter optimization technique that we have adopted is a hybrid of the random-based and the grid-based methods. The algorithm first looks for 100 random viable combinations of values and then runs a grid-based analysis within a fixed range surrounding the values which have an MSE under a certain threshold which we have chosen to be 0.004. These are the optimization functions for the MKNLMS algorithm. Here we draw 100 random combinations of values, and then in this we run a grid-based search to find the most optimum set of values. Similar functions have been created for all 5 algorithms. Now I would like to show you a demo of our project. Now this is the error convergence graph of our algorithms where we're mapping the log of the MSE against the number of data points. As you can see, the MSE falls steeply for the first few data points and then stabilizes after a while. And this graph here shows the execution times of the different algorithms. As you can see in this, the FPKLMS is the most efficient while the MNKLMS is the least efficient. This graph here shows the final values of the MSE against each algorithm. Here you can see that probabilistic LMS is the worst fit, whereas all the others lie in a pretty close range. The reason for this is that probabilistic LMS is not a kernel adaptive function. What we're trying to do here is show you the difference between a kernel adaptive filter and a normal linear regression. As you can see here, kernel adaptive filters give us a much better value of an MSE, which means that we get much better predictions when we run a kernel method rather than just running a normal linear regression.
The software was developed on the basis of the object-oriented programming paradigm. The software development technique we used in this project include extreme programming, pair programming, and weekly update cycles. We also used a Scrum framework to address the problems while creating the project.
In the future, regarding our project, we can look for ways in which it can be applied to a financial system for predicting patterns, such as stocks or inventory.